milli. And so how many spaces between meter and milli? Meter is on the baseline. Meter and centi. I said milli by mistake. All right. To centi would be 2 spaces. The small said milli by mistake. All right. And so what's the last step we have to do? That's right. Because both units are cubed, we need to cube both of these because these, whoops, wrong question. Because these things are cubed, I need to cube both of the numbers, right? Because in this question, finally, these were not cubed units. So in the last problem, I didn't cube anything. Oh, and we're going from centi to meter. So a meter is on the baseline, and then centi is here. So for a meter to deci is 1, and then deci to centi is 2. A minute ago when I asked, I said from meter to milli by mistake. Yeah, I said milli, and I meant centi. That's why I corrected myself. That's why I said 2. Okay? So when we divide that, that's going to be an answer of, okay, I don't know what I just did there. Let's fix that. That's better. 0.1234078. Did I do that right in my head? Or am I off of 0? Okay, meters cubed are 4.078 times 10 to the negative 4th meters cubed. Okay, do we get that? Okay, either answer would be right. All right, scientific notation would certainly be preferable with that one because it's such a small number. But if you didn't put it in scientific notation, I would not take off. Okay, are we okay with that one? All right, how would we do 3? All right, centimeters cubed needs to be changed to milliliters because those are one and the same, right? So, so 3.67 liters to milliliters. Who's bigger, a liter or a milliliter? Okay, so we're going to put a 1 there. And how many spaces between liter and milli? 3. So 3 zeros. So we get 3,670 milliliters. Anybody put it in scientific notation? Want me to write the answer that way? Yeah? Yes? We should change it back to centimeters cubed, which I was going to do in a moment if we needed it in scientific notation. Only if I'm in a really bad mood. So far today's been pretty good. And Mr. Long came by and put this chair together so I didn't have to. So you might get lucky today. Yeah. You should change it back to centimeters cubed because that was technically what I was looking for in the question. All right. Questions about anything in those top 3? All right. So the next 2 I need to use a calculator for. All right. So we have 5.67 second EE4 times 5.21 second EE9. I get 2.95 times 10 to the 14th. Anybody else get that? You got that? All right, then I probably punched it in right. 9.53 second EE negative 12 divide 7.43 second EE negative 5. I got 1.28 times 10 to the negative 7. You might get that? All right, probably got that right too then. Are we okay with using a calculator? Yay, nay? Okay. All right, so what are we going to do number 6? I want to find what? So what formula did we use yesterday to find volume? All right. So I gave you a what in the question? I gave you a density. I gave you a mass. I gave you a mass. I want you to find a what? I want you to find the volume, but I didn't give you a density But y'all know to do what to get the density? Look at the blue chart. So what did I give you in the problem so you'd know what to find on the blue chart? Copper. So what's the density of copper? All right, so how are we solving for the volume? Cross multiply is a fabulous idea. So if we cross multiply, we get 8.92 V equals 36.5. So if I need to find the V, what am I going to do? Divide by 8.92. Divide by 8.92. And V will turn out to be what number? 4 point what? 4.09. Now, we know we have grams, and you have to look at the top column of your blue and see what it says. So at the top of your blue chart, it says grams over centimeters cubed. So that gram is going to cancel the gram on your blue chart, and so your unit is going to be centimeters cubed. Questions? Anybody? You feel okay with the opening? Yes, ma'am.
So, so you know, like if you divide and there's so many units, they cancel out. What about if you're multiplying them? Would you just square it? Like square
Most of the things that we're doing with density, even though we're multiplying, they're going to be fractional units, and it's still going to wind up canceling out. Which one are you talking about? You want me to look at it? Tell me which homework question it is. Tell you what, since we're done with the opening, are there any questions about the opening before we move on to the homework that Eileen wants to look at? Okay, let's look at the homework then, since Eileen's got a homework question for us. All right, so homework. Number 10, since we only have 3 of them. Find those, and then I'll work the questions she's got questions on with the units. All right, so we have number 10, should be 945 grams. Number 11 should be 13.4 milliliters. And number 12 should be 82.2 grams.
What was 11?
11 is 13.4 milliliters. Yes.
I got centimeters cubed.
That's fine. Centimeters cubed is fine. I just wrote milliliters. It's centimeters cubed. All right. So, which one do you want me to show you the unit cancellation in? 10. All right. So, number 10, you've got 12.5 grams per milliliter. And we're solving for mass. And you've got 75.6 milliliters. All right, now you're multiplying these, right? So this is grams over milliliters, and you're multiplying it by a milliliter. Well, that's a whole number, or essentially it's not a fraction, correct? So it's in the numerator. This is grams over milliliters, so that's a numerator, and that's the denominator. So when you multiply, same thing as having this over 1 in math class, right? So this would multiply by this. So what's going to happen in math class if you're multiplying these two things? This and this are going to cancel each other out and go away. So you're just left with the grams behind. Okay, so that's how when you're multiplying those units actually cancel each other out. Does that make sense?
Yeah.
Okay.
So basically, you're similar.
You just cancel them out. I'm not steering you wrong, I promise. Anybody else? Everybody do okay on 12? Okay. So nobody has a question on anything? Really? Y'all are child prodigies, and first period's just slow. I know. And we're still like ahead of where first period was by like 10, 15 minutes. even at this point in class.
What do you feel for the class?
They told me they were just more precise and accurate than y'all were. They just wanted to really make sure they understood it. So nobody has a question before we do the quiz. We feel good. Okay, I'm good with that. So if you will, you need a calculator, your blue charts in case you need the densities. That's okay, try not to smash the calculators. You've already had one person smash a graduated cylinder first period. Those of you sitting next to the lab counters, please try not to stretch out like you have giant wings and spread out all of your stuff and take your notebook and sling them and throw graduated cylinders off the counter. It really just pisses me off. And she's been banished from sitting near a counter ever again. So you need your blue charts and your calculator and a writing utensil. Now, do not get out a separate sheet of paper if you're going to feel the need to write on it. I want your work on quiz paper, preferably the front side where the problems are. Guess if we finish up super early today, I could just let y'all work on your homework. This is getting ridiculous. They're going to be so far behind y'all it's unreal. Well, I'm not going to be here Friday for you. At some point, I have a feeling they're going to make us have this stupid junior meeting. We're going to lose for that. No, we have pictures of our show. They're not going to pull us out for that. Now, I do recommend showing work so that if you make a small error, I can give you partial credit. Now, if you make big errors or do something really bad that's like, oh my God, that was stupid, you should have known that, I'm not giving you partial credit for that. No, I don't get partial credit for those kinds of things. However, if it's a small error, yes, I do give partial credit. If the chart's all right and you calculate it wrong, I only take off 2 points. If you forget a unit, I only take off 1 point. So I always recommend showing your work. If you write down an answer, it's completely wrong, it's -10.
She has like 9.
She has what?
9.
Uh-huh. Oh, yeah. Let me check it.
Yes. That's also- It is even what it is. That's how it's. Some of them. Yes. She didn't say anything, so she must know she was wrong. And she wanted to know. Yes.
So I can. Okay, cool. So I'm in my 3-day window. We'll give you 3 days notice.
Stupid card. Okay. How would it go? No, he's right here. And no, we don't know because we're gonna check it afterwards. They don't even.
Okay, so you can with this.
For that one. That one. Really? Well, I think that's one of my buddies upstairs. I'm gonna be fine. Oh, there you go. Don't go, please don't.
What did I turn this in?
Just flip it upside down. And maybe you're still working. Okay. Who's still working out there? If you're still working, just tell me. You don't have to tell me you're not. Angela, you're still working? Okay. Isaac, you still working?
Nope.
Okay. Just tell me when you're done, then actually.
Really? I was just double checking.
Isaac, you're not still working away, right? Are you sure you need more, don't need more time?
Right now,
Huh?
I was writing my name.
Cash service for Friday. mean, I don't want you thinking inordinate amount of time, but I don't want to yank it out of your hands if you still like the stuff. All right. I'll have these for you tomorrow. As soon as I can put my book down beside your room. Because I should have graded third period's quiz instead of reading my book. I didn't do that either. All right, find your notes. We're going to talk significant digits the rest of class. Try that again. Oh. All right, so we're going to talk about significant digits today. Now, we're going to talk about it in two ways. We're going to talk about how to read significant digits off of equipment, and we're going to talk about how to find significant digits in numbers. All right, because a lot of you have been asking how many numbers to put behind decimals. Tomorrow, we're going to learn how to calculate with significant digits, so you will know how many places to have behind the decimal. Now, before we do that, though, there are two words we need to talk about. All right, the first one is called accuracy. Accuracy is the closeness of a number to an accepted value. Okay, the closeness of a number to an accepted value. That essentially means the correct answer. So, hopefully, for most of you today, you are accurate on your quiz. Because if you were accurate and got the correct answer, that means you scored well. Now, in science class, we have another word called precision. Now, in the English language, we often swap these two words, accuracy, precision. You use those words in English class, Miss Order or Miss Legends would know what you were referring to. It wouldn't be an issue. But in science class, accuracy and precision do not mean the same thing. Precision is the ability to reproduce the same answer repeatedly. Okay? It's the ability to reproduce the same answer repeatedly. Okay? So, precision doesn't have anything to do with being able to get the same answer. This is getting the same answer over and over again. Now, some of you this semester, when we test or take a quiz, you'll get B after B after B after B. You'll be very precise. Some of you will jump all over the place from A's to B's to C's to D's back to an A. You guys are not very precise. One way to explain this is to use dartboards. So let's say that I go play darts and I throw my darts and they land there. What can you tell me?
You're not very precise.
I am not precise at all. I got darts all over the place. So I am not precise. Am I accurate? If I hit 1 out of 3, am I accurate?
No.
Nah, I suck. Put it this way. If I go play somebody in a game of darts, am I going to win? Nah, I'm not going to win either. All right, let's say I go throw some darts and I get 3 of them there. What can you tell me now?
You're precise.
I am precise. But I am not accurate. Now, if I want to be both, where do I need these darts to land?
Middle.
I need my darts to land where I'm going to win the game. Okay? Now I can be both accurate and I can be precise. Now, most students don't have any trouble being able to do that with darts. But let's say that I have some lab data. Let's say the density of water is 0.998 grams per milliliter. Let's not say it is, it really is that. Okay? Now, that's its density. Let's say that you guys got some data of 0.996, 0.994, and 0.989. How would you think that data stacks up? Would you think we're accurate and precise or just sort of,
Precise.
No. Neither.
A lot of people tell me neither on this, okay? If y'all got this kind of data, this wall would be so doggone excited it would be unreal, okay? This is 0.99, this is 0.99, and this is going to round that up to what? 0.99. Don't let the difference in this place throw you off. That is in the thousandths place in those numbers. The numbers don't all have to be identical. This is accurate and precise. Now, if you had something like, let's say you had 0.75, 0.82, and 0.69. Okay? If you had that I'd go with neither. Okay? But this is pretty good. Yes, sir.
So you went around the 6 up?
If you did, it would be okay.
Okay.
Okay? That's still going to be 1.00, and you've got 0.998. That's still close enough that I would be really excited in a first-year class if your density was that close. Put it this way. We're going to do a density lab on Friday with wood blocks, and you're going to, when we talk about the outcome on Monday, I'll come back and talk about this again, and I'll explain why I would have been really excited about this data. Remind me if I forget. Okay, but that bottom data is neither. Now, we need to be able to get good data on Friday. So we need to be able to read the equipment in the room to the correct significant digits. So we need to talk about what a significant digit actually is. Most of you have probably not read the equipment to the correct significant digits at all in your entire life. Now, Isaac is going to be at a disadvantage because I let him read incorrectly for an entire year in physical science, okay? So he's got to overcome that hurdle. The rest of you probably haven't used it as often, so it might not be as much of a hurdle for you. The problem you're going to have is I let you do it so long and so often, you just have a lot of bad ingrained habits to break. All right, so we're going to talk significant digits. what is a I should spell it right first. Significant digits. What is a significant digit? It is all known digits plus one guess. And the piece I never make physical science students do is the guess. Okay? Sometimes students read equipment and they just innately add the guess. But most times students don't do this. Okay? And so we have to learn how to add the guess. Now, there are essentially two kinds of equipment we're going to learn to read in here. The scale and the rulers read the same way, and the graduated cylinder and the thermometers read the same way. Okay? And we're going to talk about how to do both of them. If I give it everybody time to catch up. Yay? Nay? Okay. So, let's talk about the triple beam balance. And any of the rulers. Now, we're going to do the example with the triple beam. All right, so let's just say the top beam reads 30. Middle beam reads 100. That looks terrible. Let me fix that. And the sliding beam reads 3, 4. The longer piece is always the 5. And there's the little, where the arrow piece points down on the slide. Now, everybody probably remembers that this is the hundreds on the big middle beam. This is the tens. This is the ones. So, think in math class, probably elementary school somewhere. If this is hundreds, tens, ones, what are these little lines right here? What comes next after the ones? Tens, okay? So these little things in here are the tens. All right, so those are the known digits. So what do we know in reading this? I've got two people at first period who've never used a triple beam balance. Anybody here never used a triple beam balance? The scales are sitting out on the counter. Brandon, you have it? Oh, so he's used one.
Yeah.
Okay. If you haven't or don't remember it, which is probably more the case, you just don't remember it. Tomorrow, if you get stuck, just put your hand in the air and tell me you need help refreshing. All right. So how do we add or total up these three beams? What do we do with them? Anybody remember? How do you get the mass? You got 100 on the middle and 30 on the top, and this thing slid across on the bottom. You add them up. Okay. So we'd add up 100 plus the 30 plus this 3 down here, right? So what do we get when we add all that up? 133. What tenth do we know? All right, that's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 is there, and 0.8 is there. It's a little hard to write it so small. All right, so am I all the way up to the 0.8? No. So 0.7 is my known. Now, this is my guess. You need to envision, okay, in your mind's eye. I can see that that's at 0.7. This is 0.8. And it looks like my little arrow is about right there. So I need to envision the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. All smushed between 0.7 and 0.8. If I say is halfway, then I'm going to give it a guess of 5. Does it look like it's halfway? So I'm not giving it a guess of 5. If it's less than halfway, I'm going to give it a guess of somewhere between 1, 2, 3, 4. If it's almost touching the 0.7, I might give it a 1 or maybe a 2. If it's a little more, but not quite halfway, I might go 3 or 4. If it's almost at the 0.8, I might go 9 or 8. If it's not quite halfway, but closer to 8, I might go 6 or 7. But the guess is your guess. It's what you see when you look at the scale tomorrow. It's not what I see. I grade you based on, do you have enough significant digits? So when you look up their passion, what do you think it looks like to you when you look at where that little thing is pointing? What guess would you give it? Okay, then you say it's an 8, and that's the guess it gets, because that's what you saw. If Isabel looked at it and said, I thought it looked like a 7, then she would write a 7. Okay? Questions? Now, the way you know how many significant digits it has is if it reads tenths, the guess is where? The guess is in the hundredths place. Okay, so if it reads the tenths, the guess has to be in the hundredths place. So the triple beam balance and the rulers are going to read the tenths place. Your guess has to be where tomorrow? In the hundredths place. Now, not every piece of equipment that we have in this building reads to the hundredths place. 2 pieces you're going to use tomorrow don't do that. Everybody caught up with me? Now, the graduated cylinder, for example, and the thermometer the graduated cylinder and the thermometer don't. Now, when we put water in a graduated cylinder, what does the water always do? Does it stay flat? It curves, right? So we always read the bottom of the meniscus. So, when you go to read this tomorrow, you're going to have to get down where you're level with it so you don't get what's called a parallax error. So, you got to be level so you can see where the bottom of the water is. You can't look down on top of it. You can't hold it up in the air so it's crooked. You got to squat down where you can see it so you can see it flat. Okay? Now, these are the what place? Those are the tens. So these will be the what place? These will be the ones. So what do we know? If this is 30, this is what?
31.
31. 30. 30. 30. 30. 30. 30, and so forth and so on. Okay, so what do we know that we are definitely past?
35.
All right, 35 is this line here. Is our water line up to that line? No. So we're definitely past what?
34.
We're definitely past 34. Now, if our guess or our known digits are in the ones place, where's our guess? That's right. So these are our known. So this is our guess. So again, you're envisioning 1, 2, 3, all the way up to 9. Okay, 1 through 9 is what you're envisioning right here. Is this halfway? Or more than or less than halfway? More than. So we're striking out the 5. The guess is not going to be a 5 because it's not halfway. If you said more than, what other numbers are we striking out? 1, 2, 3, and 4 are gone. So 1 through 5 is out of here. So you're looking at this thinking 6, 7, 8, or 9. Which one do you think is most appropriate, Kayla? What do you think? If you had to put a guess down tomorrow in the lab, what do you think would be most appropriate? You think it's almost touching the line. If you want to put a 9, you can. I wouldn't put a 9 because a 9 to me says it's almost touching that line right there. But if you said a 9, you have the right significant digits, and I'm not going to mark it wrong. Okay? Is your lab partner who's looking at it with you, I might argue with you and go, I don't think it's a 9 because it's not touching the line. I might say, no, I think it's more 7 or an 8 because it's lower than that. So if I was your partner, I might say, you put the 9 down because you think that's your guess. And I'm going to go lower on my guess. And I'm going to put 34.7 grams. Whoops, we're doing volume. Milliliters is my guess. Is there anything wrong with Kayla putting that and me putting that? No. They're both correct. They both have the correct significant digits. There's nothing wrong with it. It was 34. Kayla sees it this way. I see it that way. Okay? Now, what's the rule? If it reads ones, the guess is where? The guess is in the tenths place. So tomorrow when you're doing this, the graduated cylinder and the thermometer have to have the guess in the tenths place. Does that make sense?
Yes.
Okay. The hardest part for some people is just figuring out what the guess ought to be. But again, am I taking off for what the guess is? No, I'm only taking off if the guess isn't there. And these are the rules I use. Right there. If it reads to the ones place, there should be a number where? In the tenths place. If there isn't a number there, you lose points. You with me? We might have time to practice that before we get out of here. Y'all are a little bit ahead yet. Everybody good? All right, let's talk significant digit rules. If we get through this fast enough, we will have time to do that. Mm-hmm. There we go, right there. All right, we're going to talk 6 significant digit rules. You're never going to have to quote the rules to me. You're going to have to be able to use them. All right, rule number 1. All non-zero digits are significant. All non-zero digits are significant. What do I mean by that? What do I mean? Huh? Where do I stop at? Yes, 1 to 9. So if I write a number like 457, how many significant digits do I have? Okay. If I write a number like 1,529, how many significant numbers do I have? Okay. Everybody with me? They're all significant because they're not what? Zero. So what do you think the other 5 rules have to do with? If I just cover 1 through 9, they all deal with 0. Number 2 is probably the second easiest rule. Okay? All zeros between non-zero digits are significant. All zeros between non-zero digits are significant. So, if we have a number like 404, how many significant numbers do we have? The 4s are significant because why? They're non-zero. So those 2 4s are significant because they're non-zero. The 0 is significant because why? It's in between. So all 3 numbers are significant. Now, sometimes if I put a decimal in there, like that, what happens? People go, oh my God, there's a decimal there. The later rules we're going to talk about, students go, oh, that's a placeholder now, or some other weird rule we're getting ready to talk about. No, it's not. It's still between a 4 and a 4. So this 4 and that 4 are still non-zero, so they're significant. These 2 are still between the 2 4s, so there's how many significant digits? There's still 4. Okay? Now, number 3 causes problems. All zeros to the right of a non-zero digit, but the left of an understood decimal point are not significant. People look at that and go, what's she talking about? All zeros to the right of a non-zero digit, but the left of an understood decimal point are not significant. I'm talking about a number like 10, 450. Okay? Those zeros. They're to the right of the 1, they're to the right of the 4 and the 5. But they're to the left of an understood decimal point. You guys know there's a decimal there, but did I write the decimal? No, it's just understood. Y'all know there's a decimal point there. So, is that 0 significant? The answer is no. It's as if we round it off. Okay? Since we round it off, this 0 is not significant, and only the 1 is significant, so there's how many significant digits here? There's 1. How many significant digits are here? It's only 2. Now, the reason this one causes problems is, suppose I take that same number and I put a decimal there. What changes if I do that? Do I make the 0 significant? Yes, I do. It's as if I didn't round off and I actually measured to that place And so now it becomes significant, and it's 3 significant digits. Okay? If the decimal is not there, it's not significant. But if I put the decimal there, it is significant. Okay? Any questions about that? You caught up? All right, number 4. In numbers less than 1, we're talking about that 0. In numbers less than 1, zeros to the left of the decimal are what? They are not significant. Why are they not significant? Well, if you have 0.17 like that, or you have 0.17, are those numbers the same or are they different? What? They're the same number. So why do we put the 0 there? What's its function? Anybody know? What's its purpose? That's next. It's the next rule. Hang on to placeholder. Anybody know? It's only a billboard. Woohoo! Pay attention. There's a decimal behind me. If I skip it, you might miss the decimal. So when I type a test, I always put the 0 there. So in case the copy doesn't run off real good, you notice there's a decimal behind the 0. Whereas if I just typed a period with a 17 and it didn't run off real well, you might think the number was what? 17. But if I put a 0 in front of it, you're most likely going to see the decimal point. So it's just a billboard. So since that is nothing more than a billboard, it doesn't count for anything. So there's only 2 significant digits there. Now, number 5 is what Sheena talked about, the placeholders. Okay? So if you have a number like 0.0017, these zeros right here are the zeros we're talking about in this example. These zeros are between the decimal and the non-zero digit. But again, they have to be in numbers less than 1. They're in numbers less than 1, and the zeros to the left of the non-zero digit, but the right of the decimal are not significant. They are called placeholders. So, how many significant digits would I have in that number? Just 2. The 1 and the 7 are significant, and the zeros are placeholders. Now, the last rule says all zeros to the right of a decimal and a non-zero digit are significant. So this is like 65.00. Okay, 65.00. Because it is assumed that you did not round off. You measured on the scale to those 2 decimal places. So it measured to those tenths and that guess, which would mean that it was exactly on the line. That's why those are considered significant. That's like if you went to the scale yesterday. tomorrow. Yes, right, tomorrow. And it landed on the 65 on the back one, and then you slid it to the 5, and it was exactly on the line, no tenths and no hundredths.
So it's like the first.
Huh?
It's like the first.
The 65 is the first rule, and then the rest of them are because it's not rounded off. Okay, so this would be 4 significant digits. Because those zeros are significant. All right, can we try some practice? All right. Now, I want you to see if you can figure out how many significant digits there are in each of those. See what you can do, and then we're going to talk about it. And then we're going to talk about homework. Just 6 points each. I don't need a key for that. Anybody have a question? You think they're dying to know before we talk about it? Yeah?
What's
Number 9, what do you think? What's your best guess?
Yes.
If you had to guess, because I was holding a gun to your head, who would you guess what? You would be correct. You might have a question? Dying to know something before we go over? I think that's a no. Kel, anything? No. How about now? You had time to try? All right, excellent. What do you think about number one? It's what? All right, how many significant digits? What do you think? 3? All right, why did you say the first zero was not?
Because it's on the left side
Okay.
and
All right.
not between.
Okay, it's not between them and it's on the left. It's just a billboard, so that is correct. Very good. All right, what do you think about number 2? Cameron? 4. Why did you say the zeros were significant?
Because it's to the right.
It's to the right. It's rule 6. All right, what'd you say about number 3? I think it's Anna. Have the right name? Okay, what'd you say? 5 is correct. Why'd you say those zeros are significant? It's what?
It's the right, it's the decimal.
Not the right reason. You have the right answer. It's the one that I said y'all would all start talking about decimals, and it's not going to be the reason. Look at rule 2. What's rule 2 say?
Zeros are significant.
Because
All zeros between the
they're in between. It's between the 4 and the 1. So it doesn't matter about the decimal because the zeros are between the 4 and the 1. Okay? So, number 4. What did you say there, John?
I said 2.
Why? Why did you pick any of those zeros?
Because it's you're right to the decimal and then left to a non-zero
Okay, so what's the common name for all those zeros?
placeholder.
They're placeholders. All right, number 5. What did you say there, Andy?
3.
All right, so why did you pick that last one as being significant?
Because it's the same thing as something 5, right? They're placeholders.
They're placeholders, so that's why those are not significant. But you said that last one is to get 3, so why did you say that last one is significant to get 3? Because it's right.
Because it's to the right of the numbers.
It's rule 6. It's after the 4 and it's after the decimal. All right, how about number 6? Isaac?
I said 1.
In 6? How many 3s you got?
Oh, wait, come on. Wrong one.
How many 3s you got in number 6?
2
So those 2 are significant. And where's the zeros at?
in the middle.
So how many we have total? 4. Yep. All 4 fingers are right. And number 7, what do you think, Passion? Huh? Why do you say 4? I'm not gonna hurt you if you get it wrong. I'm just asking you reason, so I can understand you. Why do you say 4? What numbers are you telling me are significant, number 7? Huh? All of them are because the rule 6 is correct. 6 and 5 are significant, and then all 3 zeros are because they're after the decimal. Yes. All right. What about number 8? His name. I can't think of his name. Alexis.
I'm gonna have to go with 4.
And number which one? 8?
Yeah.
Does it have a decimal?
No, I'll say 2.
2, because the 2 zeros are behind an understood decimal there. So if there's an understood decimal, those zeros don't count. So 2 would be correct. All right, and the last one, number 9, I'm going to ask Brandon.
7.
There are 7. So why did we pick 7?
Zeros between the numbers and the decimal.
All right, the zeros have the decimal written, which would be rule 3, and the 2 at the end. are
Pardon the
rule 6.
interruption. We just have a couple of
right,
announcements
let's
before
talk
school is out for today. Tomorrow is picture day. Students are still required to be in SMOD. However, you are allowed to bring clothes to change in, but you must immediately get back into your SMOD after you have taken your picture. Tomorrow, juniors and seniors will be allowed to purchase their parking passes. If you have not picked up a form, please see Mrs. Beverly
All right,
before
on the
or
paper
after
I'm handing
school.
you right now.
And there is a bus change for this
We're
afternoon.
doing
Bus
number 1 through
331
20.
will be bus
Okay, at the top.
126.
Number
Have
1
a good
through
afternoon.
20. Don't mark anything else out because we're gonna do some of the rest of these. All right, 1 through 20. Everybody got one of those? All right, on the second paper, I'm gonna tell you which ones to do here too. There's one full passion. All right, on this one, the 3 at the top with the scales, we're doing all 3 at the top. On this one, at the bottom of the graduated cylinders, we're doing A and C. So that B, mark out. We don't have anything like A and like B. We're doing A and C. And on the back, we're doing A and C. All right. So all 3 balances, A and C at the bottom, A and C on the back. Everybody got it? All right.